So the example with heat and temperature change, what we have is a 1 kg aluminum block, initially at 10 degrees Celsius. We add some heat to it and we want to know the final temperature. So what do we know? We know the mass of the block, 1.0 kgs. We know the initial temperature. We do not know the change, so delta T is not 10 degrees Celsius. We actually need to find the change in temperature because the question's asking us what will the final temperature be. The 10 degrees Celsius will come into play later on, but it is not the change in temperature, it is the initial temperature. We do know that 3.0 times 10 to the 4 joules of heat is added. That's heat. That's Q. And again, putting that in the calculator will be a little more complex doing it that way. If we convert that to standard notation, that would be 30,000 joules. Except we need to keep 2 sig figs in that number. So if we put a line over the top of that first zero to show that it is significant. And C, again, won't be given in the question, but look it up in the data booklet. We're dealing with aluminum, so look up C for aluminum, 9.0 times 10 squared joules per kilogram degrees Celsius, which as a standard number would be 900 joules per kilogram degrees Celsius. And again, 2 sig figs. Going over to the equation, Q equals mc delta T. It's going to look a little bit different this time because we have different information. Q, now we know it's 30,000. M is 1.0. C is 900. And delta T is what we don't know. So we will multiply on the right, but this time we can just multiply the two numbers, 1 and 900, so we get 900 delta T. We need to get delta T by itself, so divide both sides by 900. And going to 2 sig figs, since that's what we have 33 equals delta T. I suppose I should have put units in there. This is temperature, so we're measuring in degrees Celsius. This is not the final answer. This is just how much the temperature has changed. But that is enough to help us find the actual final temperature. So the final temperature, what we know, we started at 10 degrees Celsius. The temperature changed by 33 degrees Celsius, meaning the final temperature of this aluminum, and again, 2 sig figs, 43 degrees Celsius.